Hey guys, and welcome back. This is a part 4 of my series on rational expressions, and today we are going to look at some complex examples on how to simplify rational expressions. Hey guys, and welcome back. Subscribe to my channel for more content like this one. This particular note is going to be the last one in our series in rational expressions. It's going to be kind of a bonus one where I'm looking at more complex or more advanced cases when it comes to simplifying rational expressions. And so the first example that I'm going to have here is going to be x over 4 minus 1 divided by x minus 4. So what do you do when you have a case like this one? This is a division of rational expressions, but the numerator here, the big rational expression on top, is not complete. It's not written in standard form. So whenever you got something like this, the first thing you need to do is rewrite all your rational expression in standard form, which means to write them with one single division bar. And so the numerator here, the first rational expression for this division, is going to be x over 4 minus 1. And so to rewrite this as a single fraction would require you to subtract these two fractions. And so you're going to realize that 1 here is actually 1 divided by 1. And so the least common denominator here is going to be 4. And so the 1 here is missing a 4, and so that's what I'm going to add to him. And so that's what I'm going to give him. And so you can think of this 1 as 4 divided by 4. And so subtracting these two rational expression would give us x minus 4 divided by 4. And our bottom portion here is technically x minus 4 divided by 1. And so now we have a rational expression divided by another rational expression written both in standard form. And so we can proceed and go ahead and turn this division into a multiplication by flipping the second fraction. And so we're going to have x minus 4 divided by 4 multiplied by 1 divided by x minus 4. Simplifying these two is going to have us cancel x minus 4 and x minus 4, and so all we have left is 1 over 4. And so this is done. Our second example here is going to be x divided by x minus 2, all plus 1, all divided by 3, divided by x squared minus 4, all plus 1. And so again, this is a combination of division slash addition of rational expressions. And so the first thing you need to do when you get something like this always is to rewrite the top fraction in standard form and the bottom fraction in standard form, which means to write them with only one single division bar. And so if you look at the top one here, the 1 is again a 1 over 1. And so the least common factor here is going to be x minus 2. So 1 is missing x minus 2 as a denominator. And so all you have to do here is add that in there. And so you're going to have x divided by x minus 2 plus x minus 2 divided by x minus 2 divided by, looking at the bottom part right now, you're going to realize that, again, 1 is sitting here by itself, so it's missing x squared minus 4 for this 2 to have the same denominator. And so you're going to add it there, and you're going to have 3 divided by x squared minus 4 plus x squared minus 4 divided by x squared minus 4. So you're going to have 2x minus 2 divided by x minus 2 on top, and on the bottom you're going to have x squared minus 1 divided by x squared minus 4. And so since the numerator and denominator are written in standard form, we're going to go ahead and factor them out, factor everything out. And so you're going to have 2 multiplied by x minus 1 divided by x minus 2, everything divided by x minus 1 times x plus 1, because that's the difference of squared, and the bottom as well, x minus 2 times x plus 2. And so let's turn this division into a multiplication by writing it as 2 multiplied by x minus 1 multiplied by x minus 2, x plus 2, all divided by x minus 2 multiplied by x minus 1, x plus 1. So now we can go ahead and just simplify out every common factor that we can find on the denominator and numerator. And so we're going to get x minus 1 and x minus 1 gone, x minus 2 and x minus 2 gone. And so we're going to be left with 2 times x minus 2 divided by x plus 1. All right. The last example that I'm going to give you here is a bonus example. It's really technically not a rational expression because it has a root in there, which you know are powers of 1/2. And so technically they are not polynomials, and so they are not technically rational expressions. But it's an interesting one to do, just so you can see some more complex examples when it comes to simplifying things that divide each other. So this one is going to be the square root of 5 minus x squared plus x squared divided by the square root of 5 minus x squared, all divided by 5 minus x squared. And so again, this is a division of rational expressions. And so you are going to want to write top and bottom in standard form, which means to write them with a single division bar. So on the top here, you see that the first term is missing the least common denominator, which in this case is the square root of 5 minus x squared. So we can rewrite this expression as the square root of 5 minus x squared times the square root of 5 minus x squared divided by the square root of 5 minus x squared. I'm going to be saying that a lot in this example, plus x squared divided by the square root of 5 minus x squared. And all that divided by 5 minus x squared. And so that's going to be giving us, if we are adding the numerators on top and keeping the denominator the same, we're going to have those two square roots. Since they have the power of 1/2 each, they're going to add up to be a power of 1. And so we can cancel out the radicals. And so we're going to have 5 minus x squared plus x squared divided by the square root of 5 minus x squared, all divided by 5 minus x squared divided by 1, because technically this is a fraction with a denominator of 1. And so now that we have a single division bar on top and a single division bar on the bottom, we can turn this division into a multiplication by rewriting it as 5 divided by the square root of 5 minus x squared times 1 divided by 5 minus x squared. And so finally we can multiply across, and that's going to be 5 divided by 5 minus x squared multiplied by the square root of 5 minus x squared. And so from here, this is actually an acceptable answer, and you can stop. If you wanted to go ahead and simplify it some more to merge the denominator together, you could notice that the first factor on the denominator here is a power of 1, and the second factor is a power of 1/2. And so if you add those two together, you get a power of 3/2. And so this expression can be written as 5 divided by 5 minus x squared to the power of 3/2. Another way to write this answer, if you were asked to rationalize the denominator, which means to write it without any fractional powers, you would have to multiply both top and bottom by the square root of 5 minus x squared. And so your final answer would be 5 times the square root of 5 minus x squared, all divided by 5 minus x squared, all squared. And this will be it. So any three of these final answer would be acceptable for this particular example. And this is it. And I'll see you in the next video. Bye-bye. Alright guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.